Hello, welcome back to another episode in CSC 263 Database Management Systems at Adelphi University. In the previous video, I briefly explained how SQL is a declarative language, not a procedural language, and how it's broken out into a data definition language and a data manipulation language. In this video, we'll explore the data definition language, and that is Chapter 7 in the textbook that we are using, and it is linked below in the video's description. So, again, the data definition language, the DDL, contains the language elements that are used to create, delete, and update metadata constructs. Specifically, what we're talking about right now in this video is how we create tables, how we alter tables, and how we get rid of tables by dropping them. There's a lot more that you can do in the data definition language, but they more or less all follow the same pattern of events. Also keep in mind that we are only looking at command syntax that carries across SQL implementations, so we're not going to look at product-specific, for example, indexing schemes. All of the languages, DDL and DML, both have these CRUD operators: create, retrieve, update, delete. Retrieve is a little different in Postgres. You could do it by querying against system catalogs, which will give you all the answers you're looking for. But since we haven't learned how to query yet, that would be a little difficult. For now, once we are in our monitor application in psql, just give the \d, lowercase d command, and it will list all the definitions of your tables, at least the table names. And then to look at the specific definitions for a given table, you just go \d space and then the name of the table that you're looking to inspect. Okay, having said that, let's take a look at what it means to create a table. I'm going to step out of the view at this point, and we're going to focus on what the terminal looks like and what my slides look like. Let's take a look what it entails in practice to create a table in a database. So before we can start creating the table, we have to know what the table looks like. So let's draw that out first. We are going to create a table that can hold students' grades. And as we have seen before in some of the examples, that means that we need to record a student ID, a course ID, so we know what term the course is graded, the term, the grade, and maybe a date on which the grade is posted. So that is our table. We have to identify a primary key. All relations need a primary key. In our case, that will be the combination of these three fields. That's going to be our primary key, so that we can post a grade for a specific course in each term for a given student. We also want to make sure that if we grade a student, that student actually exists. So we have a table called students with an ID number in there, and student ID here has a foreign key relationship pointing to this table. It is defined here in the grades table on stud ID. It points as the destination to students and in students ID. That means that this has to be the primary key, or at least it has to be a candidate key. The same thing is true for courses. We want to make sure that once we post a grade to a course, that course actually exists. And so we define the foreign key relationship here. The source is over here, because this is the table in which we want to make sure that we only put valid course IDs. The destination is here. This is the table that determines what IDs are valid. The foreign key is defined here on its source and can be referenced elsewhere. We also have to figure out what data types we're going to use, what domains we're going to assign to each of these attributes. And in this case, I have made the decision that for each of the IDs, we're just going to use a number so that we can easily count up. Really not good practice. What you should really be doing is generating some randomness to this. But for now, for simplicity, we'll start with that. So this becomes an integer, this becomes an integer, and this becomes an integer. The grade, we are in the United States, so we're going to use a letter system. That means A through F, maybe a withdraw or a drop or an incomplete. Whatever we're going to do, just to be on the safe side, we're going to take a text field of 3 characters or less. And then posted is the date on which the grade is posted, so that can be considered as a date field. Notice that we're not using any specific for example, date with time zone. That doesn't exist in the standard version of SQL. So we'll stick just to the date field and we'll deal with that as we go. This is our command prompt. The command prompt itself is kind of boring, but we're still in the Unix system. All we have to do is type psql. At that point, we connect to our database, and our database is nicely convenient, telling us that we are in the database called case. That's my first name. I've created a database for myself. And let's go create a table. Now, to do that, we can just start typing our SQL statement without having to worry about much else. We could type everything on a single line, and it would be completely okay with that. I'm going to space it out a little bit so that it becomes more easily readable. So we go to create a table, and the name of the table is students. Now, open parentheses is a syntax requirement, because once I've given this table a name, I can start defining its attributes, and that has to happen between parentheses. So, what's first? Well, the first one we said was a student ID, and we said that is going to be an integer value. Next, we set a course ID that is also going to be an integer value. The third one is a term. The term I'm going to make a string so that I can write in fall 2020 or spring 2021 or whatever it may be. 20 characters or less seems fair. It's kind of arbitrary. You kind of have to know what values you want to put in there. But once you put the constraint on there as text of no more than 20 characters, the DBMS will enforce that. The grade we said we're going to post as a also a string of, say, 3 characters long or less, and then posted was a date. So I've now defined all of my attributes by name. I've given them a name. That was part of the requirement. It's a named attribute. And it's a named attribute defined on a domain, which is the second part. This should look very familiar for those of you who have previous computer programming experience as defining variables with their data type. We have to do more though. We have to identify the primary key, and to do that we can just type the words primary key, and then between parentheses the names of the attributes which go form that primary key. So in this case, student ID, course ID, and term, and close parentheses. Even if you only just have one attribute that is the primary key, you still have to use the parentheses around it. It's just a syntax thing. Now we can add our foreign keys. Foreign key. The source is here, so we're going to say student ID, again, needs parentheses. The keyword references the name of the table to which it points, students, and then in that students, the name of the field that we're referencing. And then another one, we're just going to repeat this again, course ID references courses ID. And so at this point we have defined the name of our table, students. We have defined all of its attributes and their domains, the data types. We've defined the primary key, and we have defined 2 foreign keys, and that completes the definition for this table. We close parentheses. Notice how the prompt changes. When we first started, it had a double equal sign here. Now it has a single equal sign, and that basically means that all the parentheses are matched, but I'm still working on a query. To execute it, I just end with semicolon, and it's going to tell me that students already exists. Of course it does, because I should have called this table grades. Not a big deal. We're going to show another capability of this system. I am going to type \E, E short for edit, and it's going to open the query in my editor, and I can just change this students to grades. And save it again. Now notice that the semicolon is still here, so as soon as I save it, it will execute it. And as I executed my query, it now tells me create table. That means that the table has been defined. Had this not worked, it would have given me an error message. I can now describe what my table looks like by typing \D grades, and that tells me that I now have a table called up here grades, that it has a number of columns or attributes: student ID, course ID, term, grade, and posted, of the types integer, a variable character 20 and 3, and date. These are not null fields. That is one of the requirements of the primary key. We see that the primary key is here defined as student ID, course ID, and terms, and that we have two foreign key definitions the same way that we specified. Notice this looks a little different. That's okay. That has to do with the way that Postgres does its implementations, but all the details are there. Next, we're dealing with making changes to tables. Now, we just defined this new table grades, and I'm pretty happy with that. But I took a little bit of a shortcut when I created the table students. I only gave it an ID number. I didn't do anything else. So at this point, I probably want to add a couple of fields to the students without having to drop it and recreate it. As a matter of fact, I cannot drop this students table at the moment because there is still a foreign key that relies on this. Let's see what happens when I try drop table students. And it tells me, well, you can't because there's other objects that depend on it. Specifically, in the grades table, the student ID field's foreign key depends on this. So it won't let me delete this table. A drop table is the command to delete a table. And because that would violate integrity. So back to that, let's take a look at our students table. We want to make changes to this table, but we don't want to do it by having to drop it. So what we're going to do is alter table, students, and we're just going to continue on there and say add. What are we going to add? Well, we're going to add the column called last name, and let's say that is a varchar of 80. And it tells me, sure, that's fine, we can do that. And I can do this again, and I can add a first name field, and maybe an email field as well. And if I look at my definition for students again now, we'll see that those fields have been created just like I requested. This is a good point to also explain that there is fairly extensive help for syntax issues built into the psql client. It's accessible via the \h command, and in this case, if I wanted to know what all the things are that I can do when I'm altering a table, I can just type help alter table or \h alter table. And what we just did was this one, alter table, and in this case I said students, and I did add the word column, and then the name of the column and its data type. I could have added other things if I wanted to, but I didn't. The same way I can add, I can drop columns. I can maybe change the data type of a column or set default values. I can do all kinds of things, a lot of things actually, with the alter table command, but almost all of those are non-standard SQL commands, so we're not going to worry about this too much. For now, this is all we have to do. If we want to alter a table by adding a column, or maybe, let's make a typo in here and say, I don't know, I don't need this emails table. I just want to get rid of it. Emails column, sorry. I should say drop column emails, and it will do that for me as well. So alter table changes the definitions of a table. Now what's important to realize here is that if I add a column, all the values in that column will be not set. So that they will be unknown. And not even null, they just won't be there. If I drop a column, you saw that there was no "are you sure" thing here. It will drop the column, including all data that may already be in it. So by the time that you start manipulating these metadata structures, always realize that it immediately translates into what's happening on the actual data as well, and make sure that you have a way to recover things that you might accidentally delete by having a backup. This is probably also a good point to show you if you're done with your terminal. \q for quit drops you back onto the prompt, and then log out, disconnects your session from the server. And with that, we have seen the different capabilities of the data definition language. We now know how to create a table, we know how to drop a table, we know how to make changes to existing table definitions, and we know how to list out tables \d, and then the individual table definitions by \d followed by the name of the table that you're most interested in. All of that we do in the psql command. We want to verify that with the prompt. Also good to point out is that at least in our lab, every student is set up with their own database, so whatever you do only affects you and your databases, so don't be afraid to experiment. You're not going to step on someone else's toes or delete data that others need. That's it for the data definition language. In the next video, we'll start looking at the data manipulation language.